Hi everyone, my project is image texture clustering with grid level co-occurrence matrix. Today I will introduce my project from the 5 aspects: the problem under study, related work, proposed approaches, performance evaluation, and summary. The problem to be addressed with a color image can be divided into several mutually disjoint sub-regions by the different texture information. That's saying the values of texture in each sub-region have a higher similarity, while the values among different sub-regions have a lower one. So we are able to cluster the image by texture. Approach. In this project, I will use k-means clustering with grid-level co-occurrence matrix. K-means. K-means looks for a fixed number of clusters in a dataset. A cluster refers to a collection of data points aggregated together because of certain similarities. You will define a target number key, which refers to the number of centroids you need in the dataset. A centroid is the imaginary or real location representing the center of the cluster. Every data point is allocated to each of the clusters through reducing the in-cluster sum of squares. In other words, the k-means algorithm identifies key number of centroids and then allocates every data point to the nearest cluster while keeping the centroids as small as possible. The word keys in the k-means refers to averaging the data, that is, finding the centroid. As figure 2 shows, all the data points are clustered into 3 groups by k-means. GLCM. The grayscale co-occurrence matrix refers to obtaining its co-occurrence matrix by calculating the grayscale image, and then obtaining some eigenvalues of the matrix by calculating the co-occurrence matrix to represent some texture features of the image. The GLCM can reflect the comprehensive information about the direction, adjacent interval, and variation range of the image grid level. It is the basis for analyzing the local patterns of the image and their arrangement rules. Figure 3 is an enlargement of the texture pixel and the corresponding picture grayscale matrix. In this project, I utilized GLCM to convert the colorful image into gray image and obtain the relevant information such as dissimilarity, correlation, and contrast. Then use the gray image as input of k-means. After that, we will have the target cluster of the image. Okay, here the left picture is the original color image, and the right one is processed by GLCM. Obviously, it is converted into grayscale. Here we use this picture as the input of k-means. And in this project, I set key as 2, 4, 8, 16, 64. That means we have 2 clusters, 4 clusters, 8 clusters, 16 clusters, and 64 clusters. Conclusion. When key is 2, the leaves are mixed with the background. This mixing of color is expected because they focus on texture rather than color. When key is 4 or 8, the performance improves remarkably. And when key is greater than 8, the cluster performance becomes stable and will not greatly change. Okay, here, then I will introduce my computer program. Okay, this code I implement GLCM. Here I import some necessary libraries such as NumPy, CV2. And here I define a function to get inputs. This line reads the colorful image as grayscale. And here I will have here this function I will have the co-occurrence matrix. And in this for loop, we will have the relevant information such as contrast, dissimilarity, energy, and plot the result. In order to save time, I have already run the code, and here is the results. As we can see, there are some matrix of correlation ESM and contrast. Here is the grayscale image, and this is our original colorful image. It has been converted into a grayscale image. And the other code, here is k-means. Also, we use the grayscale image as the input of k-means. And here I convert the image into one dimension. I define the centroid, set the labels. Okay, here I cluster the k-means and set the key value as 2, 4, 8, 16, and 64. Okay, here I convert the image as RGB. Show the result as plot. Okay, here let's run the code of k-means. It will take a lot of time. Just wait a minute. Okay, we got the result. This is the original grayscale image, and k equals to k is 4, k is 8, 16, and 64. Okay, here is all I have to represent. Thank you.